Hello everyone, my name is Marcel Plch and I'm going to present about the CPython subinterpreters. And I think that it is quite a small piece of the C API, but it's quite undiscovered by people. It's not well supported, and it's in one magical circle because not very many people use it because it's not entirely finished, but it's not entirely finished because people don't use it and don't find the bugs. What do we need subinterpreters for? So when embedding Python, and I guess I haven't really explained what embedding is, and I don't expect everybody to know what embedding CPython is. So let's get to that. When embedding Python, you run the CPython interpreter inside of your own application in your program. So basically, when you write the application in C or some other compiled language, being able to link against C libraries, you can use the shared Python library and the python.h to communicate with the Python interpreter and use its capabilities. The advantages of this is that you get access to very, very rich C API, and the main thing we are interested in when embedding is PyInitialize, which creates the context, the Python context inside of the process. So now that we know what embedding is, why would I use this? Well, the reason to use CPython embedding is that you can get very low-level access to the interpreter, and there are multiple layers of the C API where where in many cases you don't even need to actually touch any internals, and you just use pointers that point at the objects. So you can most of the time treat most of the pointers in C just as Python object. Given this, you can make your app interactable with via Python. That means, for example, if you want people to type some commands into your app, they can do that using Python. You can create bindings. You can make it scriptable, etc., etc. And also Python has many library-like functionalities where in Python there is a math module. It already has some objects implemented, so you can use Python objects if you don't want to create your own implementation. You can use some communication protocols, and sometimes it's really simpler to just use what is already created instead of re-implementing the wheel. Now, all right, this is all cool. We have subinterpreters, we have embedding, C API, but where are the subinterpreters? I mean, we haven't touched them yet. So, to get to them, I have prepared some examples of how embedding is done, and I guess I'm going to make this larger. All right, so for example, over here, I have basics.c file, and in this basics.c file, there are few very simplistic examples of using this API, and this is the, I think, minimum, the very minimal code that does something with embedded Python. So, as in normal C program, I define the int main. So this could be basically any application you can imagine, any C application you write, and somewhere in its body, when I use PyInitialize, which is over here, I create the Python context inside of my process. So this basically loads the Python internals, does some initialization, and basically creates all of the things the Python interpreter has in itself into my program. And now there is a very, very high-level API function that just runs a string as Python code. So for example, here I have hello world. So I have already pre-built this example so we can see whether it behaves like that. And it prints hello world. Note that this end line is not the one that's printed. It's just to be PEP 8 compliant. And at the end, it's good practice to close the interpreter by doing finalize. And this is documented as deleting all of the subinterpreters that have been created, deleting the threads, all of these things, and finalizing the interpreter into such a state that it's reinitializable. And this behavior is quite easy to break, as there are many low-level C hacks inside of CPython and the usage of global variables. And once you use those and don't handle them properly, it's very easy to do something wrong. So, for example, as a more sophisticated example of usage of the API and embedding is, for example, you can create your own program that behaves as the Python calculator mode. And if you try this, you encounter some very common low-level problems. For example, how long can be the string that I need to load? Because now you are trying to communicate with the user from C and then communicate with the CPython from C. So that means there is a layer between the interpreter and the user or whatever above your application. That means if you don't really pay attention to the low-level details and the problematics, you get into some trouble. For example, over here at this line, I allocate 256 bytes as a buffer for a line. Should be enough, right? But once somebody types more, it's just gonna overflow and break my code. But for the sake of simplicity, I have omitted these parts of code that would make it safe. So I can demonstrate that, for example, normal Python syntax works here. But the problem is, for example, when I try to move using arrows from left to right, I mean, I'm in C. I cannot do any cursor movement, anything like that, because I haven't implemented any such thing. So, yeah. Calculator, all right. And so if you want to have some good low-level exercise, you can pick some example in Python, try to re-implement it in C, and then you will see what problematics are there already solved in CPython that you wouldn't even expect. So now, to get to the subinterpreter somehow, there are these states, thread states, and we need to differentiate between a process and a thread. A process is some whole program running in memory and has some resources. It has some memory allocated by the kernel. It has its threads. So basically threads are inside of process. And threads have, for example, their own stack, but they share the heap with other threads inside of the same process. So for example, in C, when you use a global variable and modify the global variable, you can see the results in all of the threads. And when you use subinterpreters, you don't want this to happen. So there are extensions that break things, and basically, except for embedding, there also are extensions which you can write as a module. So you aren't above the CPython, you are inside. You are writing code that is going to be run inside of the Python interpreter. So the result is different because you can import it from the calculator mode, normal Python calculator mode. You don't need to implement your own. And again, I have example over here. So I have created this demo, and when I import it, it prints that, all right, I am a demo, and I break things, and currently I have 0 calls on foo, which should state that it has that many calls on add, but I have been refactoring this code and forgot to rename the foo to add. All right, so if I do import demo and I try to use the add, it will return me a number that is the sum of the two numbers I call the function with. So to see what is going on inside of the code, we can have a look at this, and there is this C function that is basically the implementation of the add. So again, I'm at lower level than Python, so I need to watch out for overflows and stuff like that. Normally, for the simplicity of this demo, I didn't do it. But when I'm adding these two variables over here, if they were over, I don't know, 2 billion, they could overflow once I add them, which is something that doesn't happen in Python because there it is already properly handled. In C, it is not. All right, and over here, there is a global C variable, which is allocated on a heap. And when I import this module from multiple interpreters, this variable gets shared between them, which is a problem because when I create 2 different interpreters, I want them to be isolated. So if I import the demo in the first interpreter, I want it to count the calls of add only for this interpreter, because I might be using the other interpreter for entirely different application. And in the another application, I might rely on this counter, and if some other interpreter manipulates this global state under my legs, it could break my code. So nowadays, Python module does not equal C extension and vice versa, because Python module usually has more things handled. For example, the global state, there is no such thing in Python. And therefore, if you create some global variables in different modules and you import them from multiple interpreters, they are all allocated on heap. Every interpreter has their own global Python variables, while in C it's basically bound to the process, and since the interpreters are in the same process, they share it. So there is this thing that's called PerModule State, and you can tell the import mechanism as a module that, hey, I am a module and I would like 8 bytes on the heap just for myself. And the import machinery will say, all right, here are 8 bytes just for this instance of this module, and you can use it as you want. So if I moved this thing, add calls, into a state, I could use this argument to allocate whatever number of bytes I want, and it will give me it will give the module a pointer to the state, and there are some access macros for that, access functions for that, which when they fail to find the state, for example, they will return a null, set an exception, and you can safely exit. So these are the problematics that subinterpreters have nowadays, and any questions?
Yes, we do have questions. You surprised me with how fast you finished. Can I have a look at Slido, please?
Wait.
Does Blender use this API for Python scripting?
Indeed, it does, and it embeds Python because when you do this in Blender, there is this Python console. Wait. And this particular console is nothing else but, oh, I'm cut off. All right, so it's not seenable. May I ask you to switch it back to, yeah. All right, so over here there is a Python console inside of Blender, and it uses basically the same thing as I've been showing you. It is using the embedding of Python, and what I think could be useful for Blender, for example, when I create another window with the Python console, now both are running in the same process. They are running under Blender. So it might be useful for them to use, for example, subinterpreters to isolate these two consoles apart from each other, so I can do multiple experiments at once. So simply answered, yes, Blender uses this. And you can also build Blender as a C extension if you build it from source. And I think there even is package on PyPI.
Thank you very much. Anybody, any other questions? Thank you. In that case, you are welcome to catch Marcel afterwards. Give it up for Marcel one more time.